Hello and welcome back. Welcome to the second module in the Data Virtualization Architect class. This one is Data Virtualization in Action. And as I've mentioned previously, this is a companion to that first module, Introduction to Data Virtualization. It takes what we talked about in that first module and expands it and drills a little bit deeper into that connect, combine, consume mantra that we talked about. And also, we will actually go through a fairly simple example in this particular module showing the tool in action so that you not only talked about how data virtualization works, but you've actually seen it in action. You understand how we go through that connect, combine, consume, those steps, and also you can see how easy it is to use the drag and drop point and click tools that we have with the Denodo platform. So in this module, we're going to drill that little bit deeper into connect, combine, consume. We're going to talk about modeling and model layers. I want to talk about this. It's a slight detour just because it helps you understand what you're going to see when I actually open the tool in that simple project, that example project, and actually show you the Denodo platform in action. You'll understand the concept of virtual databases and folders and naming conventions, layers and models, etc. So we'll cover that. There's just a couple of slides, but it'll just help you understand the development environment, the design studio for the Denodo platform. Then we'll go and do that simple project. It will be a very simple project. It will be connecting to a database, connecting to an Excel spreadsheet, combining the data, then exposing it so it can be accessed through third-party tools. In our case, we'll use Power BI, and we'll also use an Excel spreadsheet just to connect to the data virtualization platform and access the data from those two data sources, even though it looks like we're accessing a single point from the tool's perspective. And then that will be it for this module. So let's get going. Let's talk about connect, combine, consume. This is the mantra that we talked about originally when we were talking about how you use the data virtualization platform. Connect to your data sources, define how the data should be combined and transformed and integrated, and then finally publish it so it be consumed by the users using the tools that they're familiar with. So if we look at those each one at a time, starting off with connect. This is where we connect to our data sources. A wide range of data sources is supported. That's in the next slide. And how we connect to the data sources depends on the actual data source itself. If we're connecting to a database like Oracle, we'll use a JDBC connection using the drivers that are native to Oracle. Obviously, if we're connecting to an Excel spreadsheet or a web service or an application like Salesforce, we'll use different protocols, different APIs to do that. So quickly jumping ahead and looking at the data sources that you can connect to using the Denodo data platform, data virtualization platform. This is what I call a fairly comprehensive, but it's not an exhaustive list of underlying data sources that you can connect to from Denodo version 8. This list has been changed. It's been added to all the time as we add new connections, update connections, etc. So it runs from your traditional databases, data warehouses, etc., in-memory databases like SAP HANA, Oracle times 10, your parallel data warehouses like Netezza, Teradata, Yellowbrick, etc., multi-dimensional data warehouses like SAP BW, cloud databases and data warehouses up on Amazon, up on Microsoft Azure and on Google Cloud as well. And then including those neutral ones like Snowflake, which run on multiple clouds. In terms of data lakes, we support data lake storage, whether it is up on the cloud, S3, the Azure Data Lake Store, or if you've got a Hadoop-based data lake, we support those Hadoop deployments, Cloudera, accessing data that's in HDFS files, as well as Hive, Impala, etc. Web services, so supporting SOAP and REST web services, OData web services as data sources. This part is very important because obviously if you're connecting to a SaaS application, most of them expose their data through REST APIs. So being able to access REST APIs, supporting the OAuth or SAML authentication, pagination as we get data from those SaaS applications. Package applications, files. There's still a lot of data stored in files such as Excel spreadsheets, for example, CSV files, so accessing them is very important. Cloud and SaaS applications, so whether it's social media like Twitter, Facebook, etc., or SaaS applications like Salesforce, Marketo, ServiceNow, and so on. And then messaging systems, we talked about that in the first module where we talked about the data virtualization platform being able to access messages from Kafka or JMS, etc. So we can access those as data sources as well as other parts of the infrastructure, such as ETL tools and things like that. So a very, very broad range of data sources that you can actually connect to from the data virtualization platform. When you connect to these data sources, you build what we call base views within the data virtualization platform. What actually happens is you connect to one of these data sources, you specify the data entity, the data object that you want to access, and you build a base view which is a direct representation of that underlying data entity. It could be a table in a database, for example. The data virtualization platform will go and ingest the metadata from that data source, where that metadata is available. So again, if we're building a base view on top of a table in, say, an Oracle database, the data virtualization platform will go and grab the schema for that particular table and use that to build the corresponding base view in the Denodo platform. If we're accessing a data source which doesn't have metadata, let's say a CSV file or a REST web services endpoint, the data virtualization platform can actually sample that data to try and work out the schema. So if you want to connect to a CSV file and you specify that the first line is a header line, then the first thing the data virtualization platform will do is it'll read that first line from the CSV file and it will say, okay, these are the columns in the resultant base view. Then it'll read the second line and say, okay, I'm going to try and work out what types are associated with each of those columns. So it will sample the data to try and work out what the schema is to build the base view. So the base view is, like I said, is a direct representation of that underlying data entity, table, file, etc. This abstracts away all the information about the location of that particular data source, the protocols, drivers, APIs used to access the data, etc. It also, and this is the last point about abstraction, it also actually converts the type model for that particular data entity into a common type model. And I'll explain that by using date types. Let's say I want to combine data from, I build base views on top of a table in an Oracle database, an Excel spreadsheet, and let's say a log file, a tab delimited log file. And I want to combine the data from these three base views into a derived view. And I want to do some date filtering on that. Now, the date that is stored in each of those underlying data sources, those data entities, the table in the Oracle database, the Excel spreadsheet, and the log file, is going to be in different formats. It's going to correspond to a different type model. So I need to convert them into a common type model. The date in the Oracle database is probably in ANSI SQL 99 timestamp or something like that. The date type in the Excel spreadsheet will be an integer which represents the number of days since the 1st of January 1970. The date in the log file will probably be a text string. I need to convert those to a common normalized date model, a date type, which we call, let's say, a Denodo date type, so that when I do combine that data and do date filtering, I don't have to worry if the date comes from the Oracle database, if it comes from the Excel spreadsheet or the log file. So they're all normalized into Denodo types, a Denodo date type, which very closely corresponds to the SQL-based date types. It is based on Java, but it very closely corresponds to the SQL types. So that is what we do with the base view. So now we have truly independent building blocks, which I can then join together. And this is where we go into our combine stage. I can now join these together to build higher level or derived views, as we call them. And within the Denodo platform, we do this using relational operations, joins, unions, selections, aggregations, etc. The query engine within the data virtualization platform is actually a SQL-based query engine, so obviously joins and unions and selections are the obvious things to do. And they're also readily understood by people. So anybody who's used a BI tool or used a SQL query language before, they will easily understand the data virtualization platform and how to use it. Now, you don't actually have to write SQL to do this. There are drag and drop tools which allow you to do it. And that's what we'll see when we go to this simple example. But if you do understand SQL, you can even write your own SQL queries. It's your choice. You can do it in SQL, or you can use the drag and drop tools. And really, the drag and drop tools, point and click tools, are just generating SQL behind the scenes. So I can define how I want to combine my data using these relational operations. And then when I've done that, I've got to the level of something which is meaningful and understandable and needed by the users. I can then expose that so that they can actually come and access the data using the tools that they want. This slide shows you the types of tools. First of all, on the left-hand side, it shows you the protocols and formats that we support for publishing data. SQL access through JDBC, ODBC, ADO.NET, etc. So if you've got BI tools, tools like Excel, etc., you can easily connect to the data virtualization platform using SQL-based interfaces. Web services, whether it's SOAP XML web services or REST APIs, RESTful web services, OData web services. So you can access data from, if you're writing a web app or other applications, you can access the data through APIs. And these APIs are very quick to, very easy to create, just a few clicks, and you've got converted a view into a web API. You can also expose data through web parts if you want to do SharePoint integration, or push out the data into Kafka or JMS queues, which we've mentioned before. On the right-hand side, you see the more typical tools that we see connecting to the data virtualization platform. Obviously, lots of reporting tools, whether it's the traditional reporting tools like Cognos, Oracle OBIE, or if it's the visualization tools, Tableau, Power BI, etc., even Excel, and that's something we'll see in the example that's coming up. Analytical tools like Statistica, MATLAB, people who are writing Python scripts, R scripts, etc., to do machine learning and so on. And then you have other parts of the infrastructure which can access data through the data virtualization platform. ESBs, ETL tools, that part's basically front-ending the ETL tools, so it doesn't have to deal with the complexity of maybe interfacing to a SaaS application. The data virtualization platform can interface to the SaaS application and expose its data in tabular relational form. That makes it easier for the ETL developer. So a wide range of tools that can connect to the data virtualization platform using standards-based protocols and formats. Now we'll take that brief detour into the model and modeling layers. I talk about model because when you are using the data virtualization platform, you're connecting to underlying data sources and you're building base views on top of those, which represent the underlying data entities, the physical data entities. So you could argue the base views represent the physical data model, how the data is actually stored. You then combine that data in the various ways that you decide and produce logical views on top of that data. They're your derived views. So effectively, the data virtualization platform is allowing you to go from the physical data stores to a logical representation of data, combined data entities, which are meaningful to your users. So that's what we talk about a model. Now, when you're building this model, you're going to build various artifacts. And there has to be some way of representing and storing these artifacts in a way which is logical, meaningful, and manageable. And that's what we're going to talk about very briefly in these next two slides. The first level artifact that you have for managing your artifacts are virtual databases. Virtual databases are a way that you can gather together co-related artifacts, such as artifacts which are based on maybe subject matter or department, and we see that on the diagram on the screen. We have a finance virtual database, and all the views and connections to data sources in there are related to finance data. Same with HR. You can have this by project as well. Project Bison is one of the ones that you see on the screen. So you have the freedom to create and name these virtual databases however you want, but the idea is that the virtual database should contain the views, the data connections, etc., based on that particular subject area, topic, project, whatever. So it's a way of co-locating and managing these artifacts as a group. Now, within virtual databases, you will have the concept of folders in the development environment. I'll talk about this later when we actually go into the actual tool itself. Folders allow you to organize the artifacts within a particular virtual database. You can see the folders there on the screen, and typically when we talk about the model and building your model, we talk about layers in the model. These are logical layers. They're not enforced by the tool itself. You can implement these layers as folders within your virtual database. So I can have a connectivity layer which contains connections to my underlying data sources and the base views that are built on top of those data sources that represent the data entities. They can be in my connectivity layer folder. I can have integration views, which are like intermediate views. They help me logically build, integrate together my base views, but they're not something I would necessarily want to expose to my users. So there could be integration views. They can be in the integration layer folder. And you can build it up like this. You can have as many or as few layers as you want. We've got customers who've got a connectivity layer, an integration layer, a presentation layer. That's all they need. That's all they want. You could have a single layer, but then you've got this big blob of views which are all mingled up together, and it may be confusing for somebody to understand what's doing what. So we have recommendations about layers in the model. As I say, implemented largely through folders and naming conventions. But you can pick and choose and do this however you want. There are some subsequent slides which are in your materials. I'm not going to actually walk through them, which go through each of these layers. These are the recommended layers we have as best practices. So it goes through each of these layers, and you decide. It talks about naming conventions and things like that. But you decide what you want to implement, what feels right for you. Okay, with that out of the way, let's go and have a look at the simple example. This is where I'll actually go into the Denodo platform. We'll go into the Design Studio, which is the development environment for the Denodo platform. And we will build a simple example. We will actually build connections to the data sources. We'll build base views. We'll build derived views. Then we'll go and use Power BI and Excel to actually access the data. But let's look at the scenario we've got for this particular example. So the scenario is that we're working for a retail company. They sell outdoor goods, so that's things like sleeping bags, rucksacks, tents, etc. They have operations in different countries, different regions. I think it's things like USA, Canada, and then in Europe they've got the UK, France, Italy, Germany, I think it's Spain as well. So they have these different countries, different regions, and they have marketing promotional campaigns. These could be things like buy one, get one free, discounts, etc. And these campaigns are run through different channels. It could be an email campaign. It could be an in-store promotion. It could be TV, radio, etc. So we need to do some analysis to see, of all of these marketing campaigns, which ones are most effective in which countries, which regions, etc., and which channels are most effective. So we need to combine the sales data with the marketing campaign data. And if we go and look at that, we have our sales data is actually in a database. It's a MySQL database. It's a classic star schema. We have a sales fact table and we have a number of dimensions. So we'll probably go and connect to that. Well, we will go and connect to the sales database. We'll build base views for the tables, the fact table and the dimension tables. And then we'll go and denormalize that, and we'll go and have a single view that represents the sales data. Our marketing promotion information is in an Excel spreadsheet. So we will actually connect to that Excel spreadsheet, and we will then go and be able to read the data from that Excel spreadsheet through a base view and then integrate that with the sales data. So this is the view tree. This is the model that we're going to build. We start off by connecting to the various data sources. So we'll connect to the sales database. We will build those base views. You can see it there, the sales fact table, and then those 4 dimensions: products, order methods, dates, areas. Then we will combine those. We will do joins to combine that data to have as the single view that IV full sales, which contains all the sales data. On the right-hand side, we will connect to that Excel spreadsheet, which contains the marketing promotion data. We'll build a base view on top of that. And then we will go and combine the sales data in that full sales, the IV full sales view, with the marketing promotions data. So that gives us the data that we need to do our analysis. We won't do the analysis in the data virtualization platform itself. The analysis will be performed using a tool. In this case, we're going to connect with Power BI. We've got some dashboards which will allow us to analyze that data. So the analysis is done outside the data virtualization platform. The data virtualization platform does the connection to the data source, does the integration, but the analysis should be done in a different tool, not in the data virtualization platform itself. So in terms of the steps that we're going to do, we're going to follow that connect, combine, consume series of steps that we talked about before. We're going to connect to our data sources and build the base views. So we can connect to our sales database, use a JDBC connector to do that, and build base views to represent that fact table in the 4 dimensions. We'll then connect to the Excel spreadsheet and we'll build a base view on top of that Excel spreadsheet. Once we've got the base views, we'll then start the combine phase. First of all, we will join together the sales fact table base view with the dimension base views to create that single view which contains the sales data, that IV full sales view that we saw on the previous screen. Then we'll join that view with the marketing promotions data to give us the data that we need for our analysis. And then in the consume phase, we will actually go and use a third-party tool. We'll use Power BI to connect to the data virtualization platform and actually access the data and analyze the data in that dashboard. We'll also connect with an Excel from an Excel spreadsheet so that we can actually connect to the data virtualization platform and actually view the data in the Excel spreadsheet itself, loaded into that Excel spreadsheet. So you can see there are 2 different tools, how I can access exactly the same data from those 2 different tools. Again, this goes back to that bring your own tool idea that we talked about in that first module, the freedom to pick and choose which tool that you can connect to, that you can use to connect to the data virtualization platform, but you're accessing exactly the same data. So, okay, let's jump into the Design Studio and let's go and have a look at this and put data virtualization into action. Okay, so here we are. This is the Denodo Design Studio. This is the development environment for the data virtualization platform. It's a web-based tool. I'm now going to log on. I've entered my username and password. This is where the data virtualization platform is actually located. It's running up on AWS. I'm running this browser from my laptop. So I'm going to click on sign in, and it will actually connect to the data virtualization platform running up on AWS. And this is my development environment. This is Design Studio. On the left-hand side here, you see all the virtual databases that we talked about. These are how I can segment and manage my artifacts. And over here, we don't need this one. This is going to be our work palette where we do all of our operations. Now, in your own virtual sandbox environment, you will see exactly the same as this. This is just my version of your virtual sandbox. I have the same permissions, I have the same artifacts, I have the same virtual databases, obviously with the exception of the one that's in my name. That's my personal one. You'll have one that's in your username as well. So if we go and look inside the virtual database, you'll see there are folders. I actually have 2 projects here. I've got one which is data virtualization in action. If I expand that folder, you'll see that we have all the different subfolders that represent the layers in the model. This is what I talked about, how you implement the layers of the model within the actual folder structure within the development environment. These folders are only visible in the development environment. When we go and connect that last stage, the consume stage, when we go and connect from Power BI, we won't see this concept of folders. We will just see what looks like a database and database tables. That's all we'll see. So this is only a development time construct, but it allows us to actually go and create our artifacts and organize them so that it's understandable what each one of them is. So we're going to start off by connecting to the sales database, and for that I'm going to go and create a new data source, and I'm going to use a JDBC connection to connect to the sales database. So I need to give this a name, so I'll just call it sales_DB. Now for the database adapter, I want to select the database type. This is information which tells the Denodo query engine what type of syntax or dialect of SQL to use when connecting to that particular database, when sending queries down for it. In my case, it's a MySQL database, so it's a MySQL 5, so I'll just specify that we're using MySQL 5, therefore Denodo platform, the Denodo query optimizer query engine will know to send MySQL 5 dialect versions of SQL queries down to this particular database. Obviously, I need to fill in the information about the database URL, so I'll just paste in the one we've got there. And I want to use a username and password to connect to this particular database. And with that, I'll click on Save, and that should actually create me that particular database. I'll just do a quick test connection, make sure I can access that. Yes, I can access the sales database from the data virtualization platform. So that's all good. So we've created the connection to the sales database. What I need to do now is go and create a base view. And again, base views represent the underlying data entities, in this case, tables in our sales schema. And I actually want to select all of these particular tables because it's the sales fact table in those 4 dimensions that we talked about before. Now, I am going to prefix the names with BV underscore. That's just good naming convention. BV standing for base view. It just helps you recognize that, okay, this view is called BV sales. Oh, it's a base view. I know what it is. And I am going to specify where I want to save those base views because I want to save them in their old folder to keep everything nice and neat. Having done that, I just say create selected, and it will go and create me 5 new base views. And if I look into the base views folder, you can see I've got those base views created. It was as easy as that. You would expect it to be as easy as that, let's be honest. If it wasn't as easy as that, you'd be very disappointed. So if I select any one of these base views, you can see that the schema is a direct representation of the schema in the actual database itself. If I go and look at products here, you can see it's got ID, name, length, width, height, etc., ints and a varchar. If I look at the base view, it's got ID, name, length, width, height, weight, etc., ints, and a text. So converted to the Denodo type model, but it's a direct representation of that underlying table in that MySQL database. And if I go into the execution panel, this allows me to actually send queries to the base view itself. I'm querying the base view. And I just click on a simple execute button here. This is now going and getting the data from that table in that MySQL database. And you can see here, I've got 100 rows back, and it contains information about the products, the product ID, the description of it, and then the dimensions, weight, etc. of those products. So all that's doing, if I go into the execution trace, the execution trace shows you what happens when you run a query against the data virtualization platform. What does the data virtualization platform do to execute that query? You can see it's a single trace, and at the very bottom leaf, you can see that this is a query that is sent down to the sales database, and you can actually see the query itself. So it's a simple select query, which is selecting data from the products table in that MySQL database. So I've now built my base views on top of my sales data. That was very, very straightforward. Okay, so the second data source that we need to connect to is the Excel spreadsheet. So I want to do a new data source. This time I'm going to say it's an Excel spreadsheet. Now I can do the naming here, so we'll call it marketing promotions. The Excel spreadsheet type, it's actually a 2007 or later. It's a fairly modern, fairly new spreadsheet. The data route is local because it is local to the data virtualization platform. It is not local to me with Design Studio. It's local to the data virtualization platform. This Excel spreadsheet is on the same server running up on Amazon as the DEN80EDU platform. As you can see, you can access data spreadsheets that are on, well, files generally, that are on different computers if necessary. But this is local to the data virtualization platform. And then I can go and browse and find the actual spreadsheet itself. Now notice I don't have access to any of the, just general access to the file system where the data virtualization platform is located. As part of the security mechanism within the DEN80EDU platform, you can specify that people who want to access files on this machine can only access these particular folders, for example. So in this case, it's C:\data. And I know that the marketing promotion spreadsheet is actually in this folder, and I can select that one, just click OK. That's the one I want. And I know that this spreadsheet has headers, and I want to do stream tuples because it uses a different parser when it's actually parsing the data from the Excel spreadsheet. So with that, I've got everything set up. I can say save that. And that will actually go and create a connection to that Excel spreadsheet containing the marketing promotion data. Now I can click on Create Base View, and the data virtualization platform will actually automatically create a base view for me. Now I want to change this base view because it just gave me the same name as the data source. So I actually want to edit it. And I want to change this to BV _ marketing promotions. So we follow the naming conventions. I'm going to save that. And I'm also going to be nice and tidy and drag it into my base views folder. If I go back to the summary page, if I run a query against the BV marketing promotions view, I'm going to issue a select star query against this marketing promotions, BV marketing promotions view. And this will actually be converted by the data virtualization platform to API calls to go and get the data from that Excel spreadsheet. And you can see it's returned 42 rows, and it's got all information about the different promotional campaigns that we've been running in the past year. Running from the promotion ID, the description, the dates, which countries they were running in, the particular channels that were used, whether it's an in-store or email type promotion, etc. So this is the marketing promotion information. And again, if we look at the execution trace, you can see that my query against that base view got converted into some API calls against the underlying Excel spreadsheet. Okay, so we have done the connect part of connect, combine, consume. We connected to the sales database, built those base views for the fact table, the sales fact table, and the 4 dimensions. We connected to the marketing promotions Excel spreadsheet and created that base view on top of that. Now we need to actually move and start doing our combine phase. And the first part of the combine phase, if you remember, was we were going to join together the sales fact table with the 4 dimensions so we have a single view which represents the sales data. And we're going to do that. We're going to store that in the integration views folder. So I'm going to say new join, because I'm going to do a join operation. And this brings up the work palette for the join operation. And all I do is I drag my views onto the screen. And the last one should be areas. These are the views that I want to join together, the sales fact table with the 4 dimensions. And to create the join conditions, I simply wire together the diagrams. There's a little target which points out where, which joins, which views you're actually connecting to each other. And here I want to just join up what is basically a foreign key, primary key pair. So date to date ID creates the actual join condition. And I just continue doing this for all of the different views. So product to product ID. Then I want to do it with order methods. And here I do order method with ID. And the final one we do is to areas, and again area to area ID. That's actually creating the join conditions themselves. You can see the join conditions, and these are all inner joins, etc. I could define where conditions, I could define aggregation clauses. On the output tab, you see that we've got this little warning. That's because we've got to clean up the output. We've got duplicate field names. We've got unnecessary fields that we can clean up because we've got those foreign key, primary keys that we don't necessarily need. So I'm just going to go and tidy up the output, and I do that very easily. So the first one is ID. We'll actually rename that one as transaction ID, because that's the sales transaction ID. We can get rid of the dates, the product, the order method, the area, because these are those keys that were in the sales fact table. We can remove those. We'll keep promotion ID. Actually, let's rename that as promotion ID. So that's good. The product ID, we will rename that as the SKU. Name length, yes, we'll keep all those. We don't need the date ID, so we can remove that. We don't need the order method ID. And we will rename the description to actually call it order, if I could spell, order method. We don't need the area ID. We'll leave the country. We don't need description, so we'll remove those. And where it says area, we'll actually rename that as region. That all looks pretty good. I'm just going to move the date of the transaction up to there. I do want to order this by full date. And I want to rename this into something more meaningful. So I'm going to call it IV full sales. And that's it. We've shaped the output, just took a bit of work there, just a few minutes shaping the output. But now we've got something that combines the data from the sales fact table with the dimensions and should give us a nice clean view of the sales data. So I'm going to say save that. And let's run a query against this. We'll get the maximum number of rows, which is 1,000 rows that we're going to get. The 1,000 row limit is a system configuration setting, and it's just there to stop a developer who is using the Design Studio from returning result sets with billions of rows or something like that. So if I actually run the query now, the data virtualization platform will go and retrieve the sales data from the MySQL database, the sales database that we talked about. Obviously doing those joins and actually order it by sales date, the full date that we see here. We've got the results back now, the first 1,000 rows. And you can see that we've got the data. Now, if we go into the execution trace, this shows us what actually happens within the data virtualization platform while we're actually executing that query. And if I look at the top node here, it tells us how long it took to execute that query, nearly 16 seconds to execute the query, returned 1,000 rows in the result set, etc. So all sorts of useful information here. Now, if I click on the bottom node, the last node, this actually tells us what happened with the interface between the data virtualization platform and that underlying MySQL database. You can see the query took 15.9 seconds actually in MySQL itself. And you can actually see the query that is actually being executed. You just see the SQL statement that is actually being executed against that MySQL database. And just to actually show you, I will cut and paste all of this all the way to the limit of 1,000, limiting those result sets down to 1,000. And then if I go into the MySQL workbench, I can actually paste this query into here. And this MySQL workbench is actually running on the same virtual machine up on AWS as the data virtualization platform. If I actually run that query now, it's running away on that server. So this is actually co-located. This is local to that MySQL database. The queries are running exactly the same query as the data virtualization platform was running. And this is returned as the 1,000 rows in the results that we talked about. And you can see it took 16 seconds as well. So the fact it took 16 seconds wasn't the data virtualization platform. It wasn't actually adding any real overhead to that query because it pushed the query down to the underlying MySQL database. And if we hover over here again, you can see this SQL query that was pushed down actually contains join operations. So instead of having the branches where we pull the data back from those tables, from the sales fact table and those dimension tables, and do the join in the data virtualization platform, we actually push the join operation down to the MySQL database. So the MySQL database was doing the join operation for us, doing the order by, which is the thing that took the time, to be honest with you, and then return the result sets back to the data virtualization platform, and then hence back to the Design Studio browser-based client. So this is a good example of the data virtualization platform actually optimizing the queries by pushing the operations down to the underlying databases. And when we talk about the performance and query optimization in the fourth module, the performance module of this course, we'll talk in that a lot more detail. But this is just an early example of delegating operations down to the database to improve performance, getting the database to do the work on behalf of the data virtualization platform. Okay, so we have now done this intermediate view. We've done this full sales view, and you can see that we actually have the data coming back, combined data with the data from the sales fact table combined with the dimensions. So obviously we have transaction ID, we have that full date of when the sales was made, promotion ID, then we have the product details together with the order method and country region. Now, one important thing I want to show you, and this is why I use that order by clause, Normally you wouldn't bother with the order by clause, but I just wanted to have an order by clause so I could show you a certain aspect of the data. And this is if you look at the promotion ID field, you'll see that some of the promotion ID values are null. Some of them actually have a value in there. Now then, the null, sales transactions with the null ID are what I call organic sales. This is where somebody just walked into one of the stores, they wanted a sleeping bag, they wanted a new pair of hiking boots or something like that, and they just purchased them. They didn't have a discount coupon, there wasn't any special offers on or anything like that. So organic sales. The ones with a promotional ID means that these sales transactions were a result of the promotional campaign. Somebody had got an email saying that there's an offer on, and they went and bought some products because of that offer. And when we do the final analysis, we want both the organic and the promotional sales in our result sets, so we can do the analysis looking at how the marketing campaigns fared in the different countries, different regions, different channels, compared to the organic sales as well. So we want all of those, and that does affect our final join, which we will go and do now. This final join is actually joining the sales data from this full sales view we've just built with the marketing promotion data. So we're going to go and do a new join operation. This time we're going to join the sales data with the marketing promotion data. So we will join those together. And the join condition is the promotion IDs are equal. So that's defined the join condition. However, we have those promotion IDs in the sales, the full sales view, which actually have nulls. We want to keep those, so we want to make our inner join into a left outer join. This is one of the things you can do very easily within the data virtualization platform. And then the final thing we need to do is we need to go and just clean up this output. We have got two promotional ID fields, so we'll just get rid of one of those. Remove that. And let's give this a meaningful name. So we'll call it sales with promotions. And we can go and save that. And that looks good. So again, let's run a query against our new view. Again, we'll get the 1,000 rows in our result set. And this time when we're running a query, the data virtualization platform will be getting the sales data from the MySQL database, just as we saw before. But this time it will be doing the join, the left outer join, with the marketing promotion data, which is coming from that Excel spreadsheet. And now we get the results back. And now you can see that we've got the sales data just the same as before, but on the right-hand side, the right-hand side columns, we've got the marketing promotion data. Now, obviously, for these initial sales that you're seeing with nulls, there's no marketing promotion. These are the organic sales. But if we scroll down, you start to see where we've got promotional campaigns. And if you scroll across, you can see information about the promotional campaign, what it was, when it ran, which countries it ran in, what was the channel TV, etc. in Italy. So we're obviously doing a lot of television advertising in Italy for that particular marketing campaign. We have another one here, the summer push in Canada, again, TV advertising, free items this time. So you can see all the different information about both the sales transactions and the associated marketing campaigns where they are associated. Now, this is what we would use for the analysis. Let's go quickly look at the execution trace. And in the execution trace, you see that we've got the top level view, which says that query took just over 16 seconds. Returned the 1,000 rows. But if we look a bit further down, you can see that the data virtualization platform is getting the sales data from the MySQL database. And again, you can see the query that's being run against the MySQL database. And it's then joining that, a left outer join, with the data, marketing promotion data coming from that Excel spreadsheet. So this actually allows you to see everything that happens in as that query is being executed by the data virtualization platform. Oops, sorry, you've got to drag and not scroll in this particular window. So the execution trace is that wealth of information. So now we've got the data. Like I said before, we're not going to actually go and analyze the data within the data virtualization platform itself. We're going to use third-party tools to do this. And the ones I talked about was, first of all, Power BI. This is just a simple ODBC connection to the data virtualization platform, but it allows me to go and read that data. So if I click on recent data sources and I select Denodo Virtual Sandbox, then this will actually give me that ODBC connection to the data virtualization platform. And you can see if I go into here, there is sales with promotions view there. And you can look here, and here is all of the data. And you can see it's the same data we were looking at before. The sales transaction and date, the sale, the product description, region, etc. And then we have all of the sales, the marketing promotion data. So this allows us to use, connect to the data virtualization platform, load the data into, query the data, so go and get the data into the Power BI dashboard. And now I'm in Power BI, I can start looking at the data, analyzing the data, whether it's analyzing it from a country level, analyzing it from a promotional level. Blank actually here is no promotional channels, the organic sales, etc. Or I can even look at each individual promotion to see where it's running, how it affects, like winter sale was in Italy and in Canada, etc. Winter push was just in the UK. So this is where I do my analysis. The tools, the visualization tools like Tableau, Power BI, etc. Excellent visualization tools for analyzing the data. But it's using the data virtualization platform to do the data integration, the heavy lifting. Now, in our case, it's fairly simple stuff, but obviously you can imagine if you're pulling data from multiple data repositories, instead of the data analyst having to do this in Power BI or Tableau, and Tableau, you do it in the data virtualization platform, and that way you can connect any tool you want to the data virtualization platform and get the data. And we can see this as well using Excel. I can come into Excel and I can go and get the data, and I'm going to get it from an ODBC data source. And that ODBC data source is going to be my Denodo Virtual Sandbox. And in here, I can scroll down, and here we are, sales with promotions. And if I say finish, and I can load that data, and now Excel will go and query the data virtualization platform to get the data, and the data virtualization platform will get that sales data from that MySQL database, join it with the marketing promotion data, and the results will be returned back to my Excel spreadsheet. Now, in this case, there's no limit because Excel will allow us to get all of the data back. And now I've got I think it's 158,000 rows of data back into a table in Excel. Now I can do all of my analysis in Excel itself. And let's just scroll down. If I scroll down right down to the bottom, yes, you can see 158,375 rows of data. There's a header row, that's why it's 376. So that's how we can get the data. That's how we can use any tool we want to. This is that bring your own tool strategy that I talked about in that very first module. Now I can connect any tool to the data virtualization platform, and I can get this sales with promotions data. It doesn't have to be built within the individual tools. The data virtualization platform is your data access, data integration layer. Your tools just connect to that to get to the data that they need. Okay, let's go back to the slides and just wrap up. So what we saw is we talked about, and we actually saw in that simple example, connect, combine, and consume. These are the 3 steps for data virtualization development. Connect your data sources, build those base views, combine the base views however you want to integrate, transform that data, and then expose them so that users could connect the data virtualization using those standard protocols, standard formats, using the tools that they're familiar with to access the data. And in most cases, the data virtualization platform, if you're connected from tools like Power BI, it looks like a database, albeit a virtual database. And we saw that from Power BI, we saw that from Excel as well. So very easy to build, very easy, very quick to build using the data virtualization platform. Now, I didn't work, I can't remember how long it took me, probably about 10 minutes, 15 minutes to build that example. Normally, I build that thing in just a few minutes. A very, very simple one as well. That's it for this module. Take a time to absorb it. If you have got your own virtual sandbox and you want to follow the example, there is that design guide, the guide for the sandbox that you can use to walk you through building that example step by step. See you in the next module. Thank you.